Alright, so this video we'll take another look at finding the derivative of a function using the definition. I got about 8 examples I'm going to work. Each example is going to have its own video, and here's the list of the examples I have. This will be video 1, video 2, all the way down to video number 8. Alright, so let's go ahead and get started. And so here we have the definition. It says the derivative of a function f prime of x, is the limit as h goes to 0 of f of x plus h minus f of x over h. Alright, so let's look at example 5. Alright, so before we start, let's just go ahead and write down the formula here. And that's the limit as h goes to 0. Alright, so let's see. F prime of x is equal to, so we've got f of x plus h. So what that is we're going to take the x plus h and we're going to plug it in for each of these x values. Okay, so that's the limit as h goes to 0, and that's going to be x plus h over x plus h plus 1. Okay. So you see each one of these x values here are replaced with x plus h. Okay. And then that is minus f of x. Well, f of x is just x over x plus 1. So x over x plus 1. And all that over h. Okay. So this is f of x plus h, and this is f of x. Alright, so what we've got to do now is simplify this thing. Well, all this is a complex fraction. Okay, so we look at the denominators, this one, and this one, and we get a common denominator. Well, the common denominator is x plus 1 times x plus h plus 1. That's my common denominator, and I'm going to multiply it to each term. So I get the limit as h goes to 0. So the common denominator, x plus 1 times x plus h plus 1 times this term, x plus h over x plus h plus 1 minus, and then the common denominator, x plus 1 times x plus h plus 1 times this term, x over x plus 1. And then all of that is over h times the common denominator. So that's going to be x plus 1 times x plus h plus 1. Alright, so we can see here this term and this term will cancel, and then the x plus 1's will cancel. So let's see what that leaves us with. So that's going to equal the limit as h goes to 0 of x plus 1 times x plus h minus x times x plus h plus 1, all that over h times x plus 1 times x plus h plus 1. Alright, so this will give us the limit as h goes to 0. Now this one I'm going to have to FOIL it. So I get x squared plus xh plus x plus h. And then here I'll distribute the minus x. So minus x squared minus xh minus x over h times x plus 1 times x plus h plus 1. Alright, so let's see what all cancels out. Well, the x squareds go to 0. The xh goes to 0. And look at that. Oh, the x's go out also. So I am left with, let's see, the limit as h goes to 0 of h over h times x plus 1 times x plus h plus 1. And the h's cancel, so I'm left with the limit as h goes to 0 of 1 over x plus 1 times x plus h plus 1. And so now I have plugged the h in. I get 1 over x plus 1 times x plus 0 plus 1, which is 1 over x plus 1 times x plus 1, which equals 1 over x plus 1 squared. And so we get the derivative is equal to 1 over x plus 1 squared. And there's your solution. Alright, so hope the video helped. Check out my other videos. Give me a like and subscribe, and thanks for watching.